Welcome back. In this section, we will focus on one particular aspect of climate change, increasing temperatures and extreme heat, and how changes in our global climate are affecting workplace heat stress. According to a 2023 report from the Intergovernmental Panel on Climate Change, it is virtually certain that hot extremes, including heat waves, have become more frequent and more intense across most land regions since the 1950s. Now, for workers, this means that there is greater potential to be exposed to more days above select high temperature thresholds, longer heat waves, hotter maximum temperatures, and increasing weather extremes. The two maps presented here show data from the National Aeronautics and Space Administration, projecting changes in extreme heat from 1980 to 2099. On the left, we can see that parts of the southern United States are expected to have summer days with extreme heat 65 times more often by the end of the century. Similarly, on the right, temperature increases on extreme heat stress days across the U.S. are projected to be 4 to 5 degrees Celsius hotter compared to recent trends. Extreme heat is especially concerning for outdoor workers, so we will now take a minute to talk about the demographics of the outdoor workforce. In 2022, there were an estimated 1.6 billion paid outdoor workers globally, representing 26% of the world's population 15 years of age or older. Based on formal estimates, men and younger and middle-aged workers are overrepresented in the outdoor workforce, but estimates often exclude unpaid laborers who are more likely to be women. Over the past 20 years or so, modest reductions in the number of outdoor workers has been observed. There are also a large number of outdoor workers in the United States. In 2021, figures compiled from the Bureau of Economic Analysis indicated that over 51 million Americans worked in 6 industries with the highest average heat-related deaths per year, which included agriculture, mining, quarrying, and oil extraction, construction, manufacturing, administrative and support and waste management and remediation services, and transportation and warehousing. The figure on the right from the Bureau of Labor Statistics also presents several occupations which require outdoor work at higher rates compared to all workers. These occupations include construction laborers, firefighters, roofers, paramedics, parking attendants, and more. And what we also see is that Black and African American workers and Hispanic and Latino workers are overrepresented in occupational groups requiring outdoor work. So now let's talk about occupational heat stress. According to the National Institute for Occupational Safety and Health, heat stress can be defined as the net heat load to which a worker is exposed from the combined contributions of metabolic heat, environmental factors, and clothing worn, which results in an increase in heat storage in the body. Metabolic heat can be thought of heat generated by the body. Environmental factors can be thought of as the heat gained from the environment. And clothing worn can have an additional effect based on the clothing or personal protective equipment, particularly for ensembles with lower air and vapor permeability or with greater insulation. When we think of metabolic heat, it's important to consider workers who are engaged in strenuous physical activity, as this can result in the production of metabolic heat, which can then increase their core body temperature, even to dangerous levels. Typically, workload can be classified by different levels of physical activity. Light work would be considered sitting or standing with minimal arm and leg movement. Moderate work would be continuous, modest intensity, such as light pushing and pulling or normal walking. Heavy work would involve intense upper body work, such as carrying loads or sawing, and very heavy work entails intense activity at an almost maximum pace. Environmental factors can also contribute to the overall heat stress to which a worker is exposed. Some of these factors include temperature, humidity, wind speed, cloud cover, and sun angle. In the figure on the right, we have a description of heat index from the National Weather Service. Across the x-axis, we see temperature in degrees Fahrenheit, and across the y-axis is relative humidity. And we can see that both of these factors contribute to the likelihood of heat disorders with prolonged exposure or strenuous activity. As one temperature or relative humidity increases, the likelihood of these heat disorders also increases. And so heat index is just one of the metrics that can be used to identify heat stress. Others include wet bulb globe temperature and the Universal Thermal Climate Index. In addition to environmental and metabolic factors, there are other risk factors for heat-related illnesses. Personal risk factors include different health conditions such as diabetes, hypertension, overweight or obesity, and heart disease, the use of certain medications such as diuretics, diarrhea medications, sedatives, and muscle relaxants, behavioral characteristics such as alcohol use or the intake of sugary beverages and tobacco smoking, and finally physical characteristics such as older age, pregnancy, and acclimatization status. According to the National Institute for Occupational Safety and Health, acclimatization to heat stress refers to the result of the beneficial physiological adaptations, such as increased sweating efficiency and stabilization of the circulation, that occur in the gradual increased exposure to a hot environment. Acclimatization allows for increased sweating efficiency and skin blood flow at a given core temperature, which are mechanisms that help to cool the body. In addition, circulation is stabilized, and the ability to perform work with lower core temperature and heart rate. In the United States, data suggests that the majority of heat-related fatalities among outdoor workers on their day job occur within the first few days of work in warm environments. From 2011 to 2021, there were 436 workplace fatalities reported that were attributed to environmental heat exposure. And when we talk about heat-related illnesses, there's a spectrum. The most intense is considered heat stroke, which can result in confusion, slurred speech, unconsciousness, seizures, heavy sweating or hot and dry skin, very high core body temperature, and a rapid heart rate. And in the most serious conditions, heat stroke can be fatal. Moving down, we have heat exhaustion, which is a bit less extreme, but can result in fatigue, irritability, thirst, nausea or vomiting, dizziness or lightheadedness, heavy sweating, and high body temperatures or a fast heart rate. And some more minor versions of heat-related illnesses include heat cramps, which entail muscle spasms or pain, heat syncope, which would be dizziness or fainting, heat rash or red bumps on the skin, and rhabdomyolysis or muscle breakdown. In the United States, there are 2 programs focused on the evaluation of heat-related injuries and fatalities. One is the Health Hazard Evaluations Program, which evaluates new and recurring workplace hazards, including heat stress. Mainly, it seeks to raise awareness of preventive measures based on evaluation findings. The second focuses on occupational fatalities and is called the Fatality Assessment and Control Evaluation, or FACE program. This studies occupational fatalities and provides recommendations to prevent similar deaths from occurring in the future. It does not seek to enforce federal or state standards or determine fault or blame, though.